Yeah, okay, so then we'll get to another view of what distinguishes science from pseudoscience that has been extremely popular, and some of you might have heard of it. And that theory is called falsificationism, because the idea is that what distinguishes science is that its theories can be falsified. So Karl Popper, who is the person who I first proposed this view, falsificationism, lived in the early and mid 20th century. He thought that we cannot provide any positive evidence for any scientific theory. I've already seen some of the reason, and that's that he thought, well, we cannot give any positive evidence for a theory because whatever data we have, and I showed these graphs with all the data, they never entail any particular theory. Many possible theories are always compatible with that. He also was very convinced by what is called Hume's problem of induction. And I invite you to Google that and learn about what Hume's problem of induction is. And the idea here is that it is really, we cannot, from the fact that something has always happened, to conclude that it will also happen in the future. So we cannot provide any reasons to think that a theory is true from a limited number of observations in the past. And the idea is that, well, how do we know that it hasn't, that suddenly things are changing? Well, in order to justify that, we need to say, well, they haven't changed in the past. But, well, we're just trying to show that based on what we have observed in the past, we can prove something in the future, so that we're not making any progress yet. Okay. This is not the course to learn about Hume's problem of induction. If you're interested in that, you should probably take an introduction to epistemology and philosophy of science course. In any case, Popper was convinced that this shows that we can't really provide evidence for a theory. What we can show, though, is that a theory is definitely false. And that means that theories where we can show that they're definitely false, they are falsifiable. So it's possible that there's evidence that shows that the theory is false. Now, this is certainly something that the idea has some powerful appeal to it. So it's a quote from Karl Popper. So if you're uncritical, we shall always find what we want. We shall look for and find confirmations and look away from, not see whatever might be dangerous to our pet theories. So the problem is, if you're trying to confirm your theories, is you're trying to find evidence for your theory, and you tend to always find that in some way or other. And that is indeed true that people do that, and it's known in psychology as the confirmation bias. The problem with this looking for evidence for your theory is that it's all too easy to do that in many cases. The basic idea then is that something is only pseudoscientific if it can't really be shown false. So a merely pretend scientific theory or pseudoscience is in a sense a cowardly theory. It hides from any possible evidence against it. We can find lots of positive things that seem to support the theory, but it can never be proven wrong. And I have this picture of QAnon here because I think that is such a theory. They're looking always for many signs that they connect in order to try to show that they support this. That's easy. That is not difficult to find evidence that seems to support your theory. But they should, a courageous theory would say, if this were to come out, then I know that my theory is wrong. So for example, if QAnon would be an honest theory if it said, we know that if Trump actually gets voted out of office, we know our theory is wrong, and therefore we will give up the theory. But they're not doing that. They'll just find explanations for why somehow this can still be explained. So real science, then, in contrast to pseudoscience, is courageous. It makes predictions that could turn out to be false. So Popper thought that this was the distinguishing mark of science. Insofar as scientific statement speaks about that reality, it must be falsifiable. Insofar as not falsifiable, it cannot speak about reality. So this is Popper's view about this. So this is a nice idea, but I think it's still not really quite true. There's something good about it, but it's not exactly the right view. So here's a first problem. So according to Popper's falsificationism, what scientists should do is go around testing some theory. They should come up with some crazy ideas, and then they should try to falsify it. They shouldn't try to confirm their theories. They should try to falsify theories. But it doesn't seem like that is actually what scientists do. So falsificationism doesn't seem to describe what's actually happening in science. A further and bigger problem is that there are really two ways of understanding falsificationism. One on which you apply it to a single scientific statement. Okay, now let's look. You take a scientific statement and say it's falsifiable. So, for example, you could take Kepler's law of the planetary motions. So where the radius vector, so you see, you can read it yourself here, radius vector joining any planet to the sun sweeps out equal areas and equal length of time. So that's the speed with which the planets will move around the sun. So that these areas here in blue, they're always equal. Okay, so that's Kepler's law. So suppose that is our theory now. That's our scientific statement. Okay, so that's falsifiable, one might think. But then suppose we do a test and see, well, is it actually true? You'll find again that there isn't exactly true. So have you proven it false? No, because you need to make other assumptions if for that to be true. So here's another example. When I was a high school student, we tested, I took physics and we made a little test about and test the charge of one electron. And there's a test with that. Now it turned out we ran the test, and then it turned out that what we got out was false by about 100 times. And so what we got out was 100 times bigger than the actual charge of one electron. Now, okay, we could have taken that. We falsified the theory of the charge of the electrons, but that wasn't, of course, anyone's reaction. The reaction was, go back to the lab and do the experiment better. You probably, maybe your experimental, the bench was dirty, or maybe you didn't wait for a long enough time, or maybe you did the calculations wrong, or something. Lots of things that could go wrong. So the problem is, if you take a single scientific statement, you can't really ever prove it false, because the statement says only something about anything in particular outcome of an experiment with lots of other assumptions. And that way, it's like what the creationist or QAnon says, a single statement can never be falsified. Okay, so that's a problem. If you apply it to a single statement, it really doesn't work, falsificationism. Now, we do a different thing. We apply the idea to big bags or collections of statements, so the complete theory. So now we took a look at not just the single statement of theory, but the complete, say, physics theory. So we just enlarged it. We say, well, we're adding additional assumptions. The problem is with that, if you just allow to add additional assumptions to a theory, you can make any theory falsifiable by adding falsifiable statements. So for example, here's a falsifiable statement. God created the earth 5,000 years ago, and there are fossils in South America. That's falsifiable because we can just go to South America. Are there fossils? No. Yes. So, that attempt to falsify hasn't succeeded, but it could have been falsified. So, and if you just add statements that are falsifiable, then we'll can make any theory falsifiable. So the problem then is that it seems like the falsificationism doesn't really work, because if you apply it to a single statement, go back here, then it can't really be proven false. If you buy it in big bags or collections of statements, a complete theory, then you could, by just adding more things into the bag, make any theory falsifiable. So somehow this doesn't seem to work either. So falsificationism seems to be a problem too. So then the question is, now we have tried many things to try to distinguish science from pseudoscience. We have looked at the idea that science uses experiments. That didn't work. We've used the idea that science uses proofs. We showed that that doesn't work because we don't actually get certain proofs in science. Third, we've looked at the idea that scientific statements are based on the facts. The problem with that was that the facts don't seem to entail any particular theories, and also that pseudoscientific theories also base themselves on something like facts. Then we've looked at the idea that science is distinguished by being falsifiable. That seemed to be a great idea. That seems to get at some important difference between science and pseudoscience, but it doesn't seem to be quite right either. So now the question is, well, what is really different between science and anything else? Is it just anything goes, anything could be a science, or is there still some other feature? We'll look at that in the third part of the lecture.